Imagine the scene. A vast, snow-dusted highway cuts through the heart of Yellowstone National Park. On one side, the ancient forest stands silent and watchful. On the other, a river, still partially frozen, snakes its way through the valley. Suddenly, the silence is broken by a low, powerful rumble. It is not the sound of thunder nor the groan of the earth. It is the sound of hooves, hundreds of them. A great herd of American bison, their shaggy coats dusted with frost, thunders down the asphalt. They are not grazing, they are not meandering, they are running, a tide of pure instinctual flight. This was not a migration, it was an evacuation. Where were they going? More importantly, what were they running from? In that moment, watching that primal exodus, one could not help but wonder if these ancient inhabitants of the land knew something that we did not. Something deep within the earth was stirring, and the bison, it seemed, were the first to hear its call. Are they running from something we can't see yet? The footage of the fleeing bison did not remain a local curiosity for long. In our modern, interconnected world, a story so potent travels at the speed of light. Uploaded to the internet, the video clip became an instant sensation. Millions of people watched, captivated and alarmed. The raw, untamed energy of the scene struck a chord deep within the collective human psyche. Here was a visceral, undeniable event that seemed to confirm our deepest anxieties about the natural world and the immense, slumbering power that lies just beneath our feet. For many, this was not just a video of animals on the move, it was proof. The bison, they argued, were the canaries in the world's largest coal mine, fleeing an imminent, catastrophic eruption. Of course, park officials and scientists were quick to offer a more measured explanation. But for a public primed by Hollywood blockbusters, the rational explanation felt somehow less compelling than the apocalyptic one. The idea that animals can sense impending doom is not new. In ancient Greece, historical accounts from 373 BC tell of rats, weasels, and snakes deserting the city of Helike in droves, days before a catastrophic earthquake and tsunami utterly destroyed it. In 1975, officials in the Chinese city of Haicheng ordered a mass evacuation of its 1 million residents. Snakes, which should have been hibernating, were seen abandoning their burrows. Hours later, a powerful 7.3 magnitude earthquake struck, leveling nearly 90% of the city's structures. Before the devastating 2004 Indian Ocean tsunami, eyewitnesses reported elephants screaming and running for higher ground. At Yellowstone National Park in Sri Lanka, wildlife officials were astonished to find that virtually no animals had been killed. How is it possible? The answer likely lies in very real, very sensitive biological tools. Many creatures can detect infrasound, low-frequency sound waves well below human hearing range. The grinding of tectonic plates deep within the earth or the movement of magma can generate these subtle rumbles long before the main shockwave arrives. To us, the world is silent. To them, it is already humming with a warning. Animals may sense subtle changes in Earth's magnetic field. The immense stress on rocks before an earthquake can release electrically charged particles, creating localized magnetic fluctuations that deeply disorient animals. Chemical changes in groundwater are another explanation. Pressure building in Earth's crust can force gases like radon and alter water chemistry. Animals with highly developed senses might detect these minute chemical shifts long before humans could. Yellowstone National Park is a place of breathtaking beauty. It's a world of geysers that throw steaming water into the sky, of rainbow-colored hot springs and abundant wildlife. But this stunning landscape is merely the beautiful lid on top of a terrifying geological feature. Beneath the park lies one of the largest active volcanoes on the entire planet, the Yellowstone caldera, a true supervolcano. It's not a classic cone-shaped mountain. Instead, it's a massive depression in the ground. A collapsed crater measuring a staggering 45 miles by 30 miles, left behind by an eruption of almost unimaginable violence. It has erupted in massive, caldera-forming events 3 times, 2.1 million years ago, 1.3 million years ago, and most recently, about 640,000 years ago. Each eruption was a planet-altering cataclysm. The last major eruption was more than 1,000 times larger than Mount St. Helens. It ejected vast quantities of ash that covered most of the western United States, plunging the continent into a volcanic winter that lasted for years. The reason for this volcanic activity is a hotspot. Deep beneath the North American plate, a plume of intensely hot material rises from Earth's mantle. As the plate moves over the plume, the hotspot punches through the crust, creating a chain of volcanic calderas. The interconnected nature of the Ring of Fire was brought into sharp focus by a recent, powerful earthquake near Russia's Kuril Islands. Scientists immediately began analyzing the data, not just to understand that specific quake, but to assess its potential ripple effects. Did this event relieve stress on the tectonic plate, or did it transfer it elsewhere, perhaps closer to home for cities like Seattle, San Francisco, and Los Angeles? The Earth had spoken, and everyone was listening for the echo. This concern is especially acute in the Pacific Northwest, which lies directly over the Cascadia subduction zone. Here, the Juan de Fuca plate is being forced beneath the North American plate. For centuries, this fault has been locked, building up incredible stress. The big one would be a magnitude 9.0 or greater earthquake, followed by a massive tsunami that would devastate the coast from Northern California to British Columbia. Further south, California lives under the constant shadow of the San Andreas Fault. While not expected to produce a magnitude 9.0 megathrust quake, a major rupture could still cause catastrophic damage to Los Angeles and San Francisco. Experts constantly warn these cities face not a matter of if, but when. The slow, inexorable movement of the plates guarantees that stored energy will eventually be released. The Russian quake is a reminder that the clock is always ticking. In the wake of events like the Yellowstone Bison video, two distinct narratives emerge. One is the story told by science, which is cautious, evidence-based, and deals in probabilities. The other is told by conspiracy theory, which is often dramatic, certain, and emotionally compelling. The scientific community, when examining claims of animal prediction, is intrigued but demands rigorous proof. While anecdotal evidence is plentiful and fascinating, it is difficult to study systematically. Conspiracy theories offer simple answers to complex questions. They often suggest authorities are hiding the truth about imminent eruptions to prevent mass panic. In this view, running bison are not just potential indicators, they are absolute proof. Real scientific research, such as the Icarus Initiative, takes a different approach. Scientists are attaching sophisticated sensors to animals in seismically active regions, tracking their movement, heart rate, and biological data in real time. The goal is to build a massive database that can be correlated with geological data. If tagged animals all begin behaving erratically hours before an earthquake, it would provide the first truly robust, large-scale scientific evidence that animals can act as biological forecasters and peer review. Conspiracy theories seek to confirm pre-existing beliefs, often by ignoring contradictory evidence. Yellowstone does not exist in isolation. Its volcanic heart is linked to a much larger system, the famous Ring of Fire. Stretching for 25,000 miles, it's home to more than 75% of the world's active volcanoes and 90% of all earthquakes. The immense Pacific Plate is colliding with smaller plates like the North American and Eurasian plates. This subduction process is incredibly violent. As one plate is forced into Earth's mantle, it melts, creating magma that feeds the region's volcanoes. A major seismic event along the Ring of Fire can send shockwaves across the entire plate, potentially disturbing volcanic systems hundreds of miles inland. It is a planetary chain reaction, a game of geological dominoes. When a major earthquake strikes off the coast of Japan or South America, seismologists in North America pay close attention. The entire system is a web of tension, and a twitch in one strand can send vibrations rippling through the whole network. We are left at a fascinating and critical crossroads. On one hand, we have the steady, methodical work of science, building its case brick by brick. On the other, we have this deep, ancient intuition that the creatures we share this planet with are tuned into its rhythms in a way we have lost. Imagine a future scenario. The Icarus project suddenly shows that thousands of tagged animals across the Pacific Northwest are simultaneously moving inland, their stress levels spiking. There are no other immediate signs of danger. Would we sound the alarm? Would we dare to evacuate cities like Seattle or Portland based on the behavior of birds and goats? It is a profound dilemma, pitting our faith in technological creations against the instinctual wisdom of the natural world. The challenge lies in our modern mindset. We have become accustomed to trusting data from machines, living in climate-controlled boxes, insulated from the very planetary signals that other animals experience with their entire bodies. Perhaps the true lesson from the running bison of Yellowstone is not about predicting the next eruption, but about our own relationship with the planet. It is a call to pay closer attention, to relearn the art of observation. Whether they are fleeing a harsh winter or the stirrings of a supervolcano, their behavior is a message. It tells us that Earth is a living, breathing, dynamic system. The next step is to build a better, more attentive relationship with our world and to decide before the ground begins to shake if we are truly willing to listen to all of its voices. Thank you for joining us on this journey through the mysteries of Yellowstone and the hidden signals of our planet. If you found this story intriguing, don't forget to hit that subscribe button for more fascinating explorations into the wonders of nature, science, and the unexpected connections that shape our world. We'd love to hear your thoughts. Do you believe animals can sense what we can't? Would you trust their instincts in a moment of crisis? Drop your ideas in the comments below, or share this video with someone who loves a good mystery. Remember, by staying curious and connected, we become better stewards of the earth we all call home. Subscribe for more, and we'll see you in the next adventure.